Okay, so when drawing a parabola, the first thing we're going to do is use the rectangle method. Now I have a simple rectangle here, 100 by 120 high. We want to fit the parabola inside that. The first thing we always do is find the center line, depending on which way the parabola is orientated. In this case, we're going to have the point of the parabola up here, or the very roundest part, which is known as the vertex. At the very top. Which means that two other points in the parabola would pass through that corner and that corner. So what we need to do is find a series of points in between to create the curve. The curve we're looking for is taking a section from a cone, and it would leave us with a shape that looks like that. Okay, and other conics that we would know about would be the ellipse, the elliptical shape, and you may have come across a hyperbola. So to find these parts, the first thing we're going to do is, or the other points, what we're going to do is divide each side into equal parts. So it doesn't matter how many equal parts. The first thing we do is we start off with a random line, random angle. Doesn't matter how long. We get our compass and split this line up into equal parts. Doesn't matter what size you set the compass to, so long as you keep it the same between each segment. So I'm going to split it up into 4 parts. Now our next step here is to join the last point. So 1, 2, 3, 4, the fourth point to the end of that line that we're trying to break up. And this is a construction you would have done earlier in first year. We're going to now draw a line parallel from each of those points. So to do that, we line up the first set square with the line we're after drawing, and we line up the other one just at the base of it. And now we slide it back until we get to the next point. I'll continue to do so for the remaining 2 points. At this point, we join each of these points back to the vertex at an angle. And the last point would join there, but we have the last point located. So that is point, we call this 0, this is point 1, 2, 3, 4. We're now going to do the same thing down the bottom. We're going to draw a line, random angle. We're going to put equal divisions. And we join the last point to the center point of the baseline. So we're just doing half of the parabola first. Now again, it's the fourth point. It's not the end of the line, it's the fourth point. Leaving that in position, we put the other one at the base of it. And slide back parallel. And we bring each of those points straight up using our t-square and set square. Now we can label them as well. So we had 1, 2, 3, 4. We likewise have 0, 1, 2, 3, 4. Now what we must do is plot the points. For example, 1 and 1, where they intersect, is our first point. 2 and 2, and 3, 3. That creates our line. So we just join our points together from 0. Into a nice round top through that point. We've only one half of our parabola drawn though. The next one we're going to use is a construction we use in transformation geometry called axial symmetry. So we're going to use our central axis to bring our points through and step them across. So to do that, we bring a line horizontal across the page. We get our compass. We measure from the axis. And likewise for the other 2 points. And we simply continue then our curve up through those points. To complete our parabola.